Have you ever just stopped and wondered how it all fits together? The universe, life, everything we see around us. Well, it turns out there are four fundamental sciences that explain, well, pretty much everything. But here's the thing. They aren't just separate subjects we learned in school. No, they're all interconnected layers of a single, incredible story. The story of our reality. So let's dive in and start peeling back those layers.
Galileo really hit on something huge with this. He said the laws of nature are written in the language of mathematics. Just think about that for a second. Our entire universe, from the biggest galaxies down to the tiniest little particles, is built on a code. And the most amazing part? It's a language we can actually learn to read.
And that, right there, brings us to our first pillar, mathematics. This isn't just about numbers and boring equations. It's the foundational language we use to describe reality itself.
Think of it this way. Just like we use language to share our thoughts, we use math to share ideas about the patterns of the world. I mean, ancient civilizations used it to build pyramids, to trade with each other, to measure their world. It's really the original human tool for making sense of it all.
And what's so cool is how universal this language is. You've got engineers using it to build bridges, doctors using it to figure out the right dose of medicine, researchers using it to prove their theories, and pilots using it to navigate the skies. Heck, even gamblers are using it to calculate the odds. Math is literally woven into the fabric of our world.
And this brings up a really crucial point. This whole idea of being a math person, it's a complete myth. Brain science has shown us there's no such thing as a math brain. It's a skill. It's a way of thinking that, honestly, anyone can develop once we see how it connects to the real world it's trying to describe.
All right, so let's move to our next layer and see how this all builds. If math is a language, then physics is what writes the rules of reality using that language. So, at its core, physics is the science that uncovers the fundamental laws that govern how everything interacts. It's the field that tackles the biggest questions about matter, energy, and how they're related. It's the how and the why for the entire cosmos.
And the scope of physics, it's just mind-blowing. It operates on every scale you can possibly imagine, from the super strange quantum world of atoms and subatomic particles, all the way up to the massive cosmic dance of stars, planets, and entire galaxies.
And because its scope is just so vast, physics gets broken down into all these specialized fields. You've got acoustics, which studies sound, optics, which studies light, thermodynamics, looking at heat and energy, and, of course, astronomy, which is gazing out at the cosmos. Each one is like a deep dive into a different chapter of our universe's rulebook.
Okay, so we have the language, that's math, and we have the rules, that's physics. But what is everything actually made of? Well, that's where our third science comes in, chemistry. Chemistry is the science of the universe's building blocks. It's all about matter, what it's made of, how it's put together, and how it changes. It explains everything, from the water you're drinking to the very air you're breathing right now. Here's a perfect example of chemistry in our everyday lives. Have you ever just looked up and thought, why is the sky blue? It seems like such a simple question, right? But the answer is pure chemistry.
You see, it's all about the nitrogen and oxygen molecules in our atmosphere. When sunlight hits them, they act like these tiny little prisms scattering the light. But here's the catch. They're way better at scattering the short blue wavelengths of light than the long red ones. So all that blue light gets scattered all across the sky for us to see. That's chemistry, happening constantly right above our heads. Pretty cool, huh?
So we've got the language, we've got the rules, and we've got the materials. Now we get to see what happens when those three things come together in the most complex and fascinating way possible, life itself. And this is the realm of biology.
The word itself tells us everything we need to know. Bio, from the Greek for living, and lology for study. So biology is the discipline that explores that deep question of what it even means to be alive, from the tiniest microbe to the biggest whale in the ocean. So what's the difference between a rock and a rose? Well, biologists have identified 7 key characteristics that all living things share. As you can see here, it's everything from having a complex internal order, to processing energy, all the way to adapting to the environment over generations. If something checks off all 7 of these boxes, scientists are pretty confident that it's alive.
All right, let's bring it all together. Because as you've probably guessed by now, these 4 fields aren't separate at all. They flow right into one another, building the single unified story of our universe.
It all starts right here.
Math gives us that abstract, logical foundation. It's the language that makes describing everything else even possible. Then, physics uses that language to write the fundamental rules of the universe, things like gravity, energy, motion. These are the laws that all matter, no matter what, has to obey. Next up, chemistry explains the stuff, the matter, that has to follow those physical rules. It's all about how atoms bond together to form molecules, creating everything from a drop of water to a giant star. And finally, biology is the most intricate, complex result of all these layers working together. Life is what happens when chemistry, governed by the laws of physics and described by math, becomes organized in this amazing way. Just think about photosynthesis in a plant. It's a biological process for sure, but at its heart, it's chemistry. And that chemical reaction is so mind-bogglingly efficient, it seems to harness the weirdness of quantum physics, particles literally exploring multiple paths at once just to find the best route for energy. It's a stunning example of how these layers aren't just stacked on top of each other, they're deeply, deeply interwoven. So this framework, this interconnected story of math, physics, chemistry, and biology is our guide to making sense of everything. And it leaves us with one last, powerful question. With these tools in our hands, what incredible secrets of the universe are we going to discover next?